All right, in this video, we're going to go over what in the world is a random variable. Okay, so you know the drill. We're going to start off with some definitions, and then we'll get into a couple of examples here. Okay, so what's a random variable? A random variable, which we often use the symbol X, the capital X. A random variable X consists of all the numerical values of a random experiment. So if you perform a random experiment and you get some numerical value out of it, that is a random variable, right? So for instance, let's say that we roll a six-sided die, a single die. The random variable could be the number that we land on because that's a number, or that's a numerical output from a random experiment. Okay, so there are two types of random variables. We have continuous random variables, and we've talked about continuous variables in this class before. You know that continuous variables are mostly variables that you measure where they have an infinite number of possibilities, where you can, so for instance, right, like if we wanted to know, let's say the random variable is a person's randomly selected height, right? A randomly selected person's height. There's an infinite number of possibilities for that, right? And for that, it's going to be continuous. Discrete, on the other hand, doesn't take all of the possible values within an interval, right? Discrete, I like to think of it as having gaps in the number system, right? So with discrete, the random variable could be the number of people that are in a randomly selected classroom. Well, there can only be 0 or 1 or 2, right? We can't have 2.5. Whereas we could have somebody that is 66.5559 inches tall, right? So that's why height is continuous. But something like discrete, like the number of people, that is going to be, well, as I said, discrete. Okay, so in this chapter, in the next chapter, we're going to be dealing with some examples of discrete random variables. We've already kind of touched on continuous random variables with the normal distribution. And so for the next two chapters, we're going to talk about some discrete random variables. The collection of all probabilities of possible values. The collection of the probabilities of all possible values of a random variable is called a probability model. So a probability model just basically lists out all the values of that random variable, and it gives you the associated probabilities. That's what a probability model is. But keep in mind, since it's a legitimate probability model, it has the same properties as what we've talked in previous lectures. Each probability must lie between 0 and 1. It could include 0 and 1, but it must be between 0 and 1. And if you add up all of the probabilities in your model, they must sum to exactly 1. Okay, moving along here. We're going to be asked to calculate the mean of a discrete random variable. So they're going to give you a probability model and ask you to calculate the mean. Well, in the probability terms, the mean is also called the expected value. So the expected value, as the name implies, tells you the number that you expect to get from this experiment. And it's the mean, okay? So the mean and the expected value are the same thing. Those terms are interchangeable. They're synonymous. And so how do we calculate the mean or the expected value of a random variable? What we do is we take, so mu is the mean, right? It's the summation. So we're going to add up a bunch of things. So what are we going to add up? We're going to add up these pairs that we're going to be multiplying. We're going to multiply the value of x, the output of that random variable, and we're going to multiply it by its associated probability, right? So let's say there's a probability of 20% that we get the value 1, right? Well, we would take 1 times 0.20 and then add on all those other pairs. We'll do an example in a second that'll hopefully clear it up. The variance of a discrete random variable is this formula. So what we do is, once again, we're summing up something. So what are we summing up? We're summing up, we take the value x, remember x is the value, minus the mean, and we square that difference. It's just like we're getting a squared deviation like we did before with variance. But this time we're going to multiply it by the probability of getting that value. And then as we know from before, the standard deviation is just always going to be the square root of the variance. So once you get your variance, just take the square root to get the standard deviation. I promise you guys we're going to go over some examples. In fact, let's get into one right now. Consider the following probability model of a discrete random variable. They want us to find the mean, and they want us to find the variance and the standard deviation. So really quickly, I want to go over how do we read this table, right? So in this particular table, the way it's set up, across the first row, we have all the possible values for this random variable x, okay? So according to this experiment, x can either obtain the value of 100 or 200 or 300 or 400. And then the row below it tells us the probability that we get said outcome from the random variable, right? So the probability that we get 100 is 0.1 or 10%. The probability we get 200 is 20%. The probability we get 300 is 50%. And the probability we get 400 is 20%, 0.2. So with all that information, they want us to find the mean, the variance, and the standard deviation. Well, let's kick things off with the mean, all right? The mean, aka the expected value. Okay? So I'm going to use our Greek symbol mu. We've seen that before. That means mean. And I'm just going to copy down our formula. It was the summation of the value of the random variable times the probability that we get that random variable. Okay? All right. So what is that going to look like for us? That's going to look like this. Let's go with a different color. The mean will equal, so ask yourself, what's the first value of x? The first value of x is 100. So we're going to take 100 and multiply it by the probability that we get 100, which is 0.1. That's what it means to be x times p of x. Well, since it's the sum, we're going to add. And now we go on to the next value of x. It's 200 times 0.2 plus, and I'm hoping you're starting to see the pattern now, 300 times the probability we get 300, which is 0.5. And then lastly, plus 400 times its associated probability of 0.2, 20%. All right. Now, let us put all of this into the calculator. So I'm going to come to my calculator, and I'm going to type it in just like we wrote it down. We do 100 times 0.1 plus 200 times, and I forgot that probability, times 0.2 plus 300 times, I believe that was 0.5, and then plus, do it again, let's do 400 times, I believe that was 0.2. Yeah, it's got to be a 0.2. Then we hit enter, and we get an answer of 280. Okay? All right, 280. So what that means is that basically, this mean is a very, very long-term average. If we were to play this game an infinite number of times, a bunch of times, sometimes we're going to win 100, sometimes we're going to win 300, sometimes 200, sometimes 400. If I were to average all of those outcomes out over a very long time, the average will come out to be 280. That's what that means. Okay? So the expected value from playing this game is 280. Really quick, before I move on to the next part, I want to be clear on what we mean by a probability model. So remember I told you that there were those conditions, right? Each probability has to be between 0 and 1. Notice for every single probability, it's between 0 and 1. Also notice if we add up all those probabilities, they add up to 100%, right? Or 1. If I take 0.1 plus 0.2, that is 0.3, right? So let's do this. If we take 0.1 plus 0.2 plus 0.5 plus 0.2, let's see, 0.1 plus 0.2 is 0.3, plus 0.5 is 0.8, plus 0.2 is a 1.0. All right, so it meets all the qualities, all the conditions necessary for a probability model. Okay, so I just wanted to mention that before going on to the next part. All right, so now we need to calculate the variance and the standard deviation. The variance and the standard deviation. Well, the variance of x. It's the summation of, we take, what was it? It was x minus the mean, that quantity squared, times the probability of x. Okay? So the first step when finding the variance is you've got to find the mean first. And we've already done that. We know the mean is 280. So now let us fill in our formula. So let's see here. Give myself enough room here. So the first value is I take x. My first x value is 100 minus the mean of 280. That quantity gets squared, and then it gets multiplied by the probability that we get a 100, which we know is a 0.1. Plus, now we move on to the next x value. Next x value is 200 minus the mean, which is 280. Square that up, times the probability that we get 200, which is 0.2. Plus 300 minus 280, that quantity is squared, times 0.5. Plus lastly, 400 minus 280 squared times a 0.2. Okay. So hopefully you can see how we were able to fill in that formula. Now let us go in and calculate this. All right. So we're going to take, let's see here, 100 minus 280. That quantity is squared times the probability of 100, which we said was a 0.1, plus 200 minus 280, quantity squared, times, I believe that probably was 0.2, plus 300 minus 280 squared up. And then we multiply that by 0.5. Plus lastly, 400 minus 280, close parentheses, square, hit my x squared button, times 0.2. What's that probability? And we get 7,600. 7,600. Okay, so that is the variance. And lastly, to get the standard deviation of x, which is the sigma symbol, it is simply the square root of 7,600. It's the square root of the variance, which equals square root 7,600 is, we'll go 2 decimal places, 87.18. So that gives you an idea of the spread of the possible outcomes for this experiment. Okay, so I hope that shows you how to calculate both the mean, which is the expected value, and the variance and standard deviation of a discrete random variable. Last, let's get into a quick little example application of this, and then we'll be done. All right, we got a novel here. So a man buys a racehorse for $20,000, and he enters it into 2 races. He plans to sell the horse afterwards, and he wants to make a profit. If the horse wins both of those races, its value jumps up to $100,000. If it wins only one of the races, it'll be worth $50,000. If it loses both races, it'll be worth $10,000. If the man believes there's a 20% chance that the horse will win the first race and a 30% chance that the horse will win the second race, the man believes that there's a 20% chance that he'll win the first race, 30% chance that he'll win the second race. Assuming the 2 races are independent, we are to find his expected profit. Okay? So what I'm going to do is I'm going to highlight this word right here. Expected profit, as we just talked about, means find the expected value, aka find the mean. My pen doesn't want to write. Come on. There we go. Find the expected value, better known as the mean. Okay? Well, in order to do that, we need to create that table, right? We need to create that probability model table. And that's exactly what we're going to do here, okay? Except for I'm going to make my table. The last one was, horizontal? I'll make this one vertical, okay? So here we go. We're going to make a table, our probability model. And the random variable x, very important, folks, the random variable x is going to represent the profit that he gets from selling the horse, okay? And then p of x is going to represent the probability that he gets that profit, okay? So let us go through and think about all the possible profits, all the possible values for our random variable x here, right? So they tell us that if he wins, so he's running 2 races. He's running exactly 2 races. So what can happen? The horse can either win both races, wins both races. That will be one outcome. He can win just the first race, okay, and loses the second. He can win just the second race and loses the first, or he can lose both races. Okay? So let's keep that in mind, folks. Those are all of our possibilities when it comes to what can happen here, okay? As far as our profit. So the key word in this, once again, is profit. So profit means what's left over after you subtract away what you paid for. For instance, if he wins both races, he wins $100,000. But how much did he pay for that horse? He paid $20,000. So the profit he would get from winning both races would be $80,000. Okay? Where did that come from? That came from, we took the $100,000 that he gets from winning both races and we subtracted away $20,000. I'm sorry for my cramped handwriting. So that was $100,000 minus $20,000. Okay? What happens if he wins just one of the races? Well, it says that the horse will be worth $50,000 in that case, if he wins just one of the races, either the first or the second. So once again, we take $50,000 that he's now worth minus the $20,000 that we bought him for. We get a net profit of $30,000. Okay, once again, that was $50K minus the $20K that we bought the horse for. And for the same reason, if he wins just the second race, it's going to be $30,000, right? If he loses both races, the horse will be worth $10,000. Okay? Well, the horse is worth $10,000, but I paid $20,000 for it. So now my profit is a net loss of a negative $10,000. Okay, so if he loses both races, the profit actually won't be a profit, it'll be a loss of $10,000. So make sure it's a negative there. Okay, next let's talk about how do we calculate the probabilities. Well, in order for him to win for him to get an $80,000 profit, he has to win both races. Remember, there's the first race. They tell us at the first race, there's a 20% chance that he wins. And for the second race, there's a 30% chance that the horse wins. And so because, I know this is going way back, remember the multiplication rule? Because the events are independent, if I need to win both races, I need to win the first race and the second race. So how do I figure out that probability of A and B? I multiply those together. So the probability that he wins both races will be 20%, 0.20, times 30%. Which I believe that ends up being a 0.06. Let's double check that in our calculator. 20% times 30%, yes, 0.06. So this is the case where he wins both races. Okay, so that's the probability for us having a profit of $80,000. What's the probability he wins just the first race? So what has to happen here? We have to win the first race. What's the probability we win the first race? 20%. And then we have to lose the second race. Well, if there's a 30% chance that we win the second race, the probability that we lose that second race is 70%. Okay? Where do we get 70% from? You bet it. It was the complement rule. 1 minus 0.30, right? If there's a 30% chance that the horse wins. There's a 70% chance that the horse loses. All right, so what does that give us? If we take 0.20 times 0.70, that gives us a 0.14. Feel free to verify that in your calculator. Next, what if he wins just the second race? It's kind of opposite of what we just did, right? So now if he wins just the second race, he has to lose the first race. Well, there's a 20% chance that he wins the first race, so the probability he loses is 80%. Okay? Times the probability he now has to win the second race. That probability is 30%. And that should give us a 0.24, I believe, yeah. And then lastly, he needs to lose both races in order for us to have a profit of a negative $10,000. Well, how does that happen? He has to lose both races. So if there's a 20% chance that he wins the first race, 80% chance that he loses the first race. If there's a 30% chance that he wins the second race, there's a 70% chance that he loses the second race. And if I take 0.80 times a 0.70, we should get 56%. And let's double check. Remember, if we add up all these probabilities, they should add up to 1. So let's see, 0.06 plus 0.14, that's a 0.20. 0.20, matter of fact, I'm not wasting my brain space. Folks, we got a calculator. If we take 0.06 plus 0.14 plus 0.24 plus 0.56, hey, we get 1. Okay, so that was, to me, that's the hard work in this, is figuring out how to get this table filled out. Now that we have the table filled out, we can go ahead and calculate the expected profit, which is the mean. Once again, the mean is the summation of the value of x, in this case our profit, times the probability we get that profit. Okay, so what is that going to look like? That's going to be, we take $80,000, that was the first profit we calculated, we multiply it by 0.06, plus 30,000 times 0.14, plus 30,000 times 0.24, and lastly, minus, right, because we have a negative profit here, minus $10,000 times 0.56. So let's put that into our calculator. All right, let's see here. 80,000. Make sure I get the right number of zeros in there. 0.06 plus 30,000 times 0.14 plus 30,000 times 0.24 plus, minus 10,000 times 0.56. Okay, that looks good to me. We hit enter and we get 10,600. Hope you all got the same. So what does that mean? That means that this man can expect a profit of $10,600 with this horse. Okay, oh, that's too many zeros. 10,600. All right, folks. I hope this helps you out with random variables. Look forward to seeing you guys in the next one.